Hello, everyone. I'm Kanchana Patlola. I'm one of your co-hosts for the 5 days of AI Agents Intensive course. I'm here with Anand Navalgria. Anand, why don't you say hi?
Hi everyone, Anant here. Happy to host you again today.
Thank you. So we are in day 4 of the AI Agents Intensive course. Thank you for staying with us over the last 4 days. We are super excited and thrilled seeing all the momentum across all the platforms in your feedback, in your questions, in your engagements with us. We really appreciate it. So keep engaging with us and keep asking us questions, and we are here to answer it. As you all know, this is a 5 day course, and the course is designed in such a way that we are going from basic to advanced in several different ways. You have the option to pick white paper, companion podcast with it, code labs, which are mandatory and optional. And towards the end, tomorrow, we have an exciting announcement with Capstone and also the production goes. Of course, I encourage all of you to join. And this announcements are all happening through your email, which was registered, or through Discord announcements, or you could also see it in the course platform. As this is a village, it is not possible without the moderators who are keeping us engaged. So please ask them questions. They are here. They have a real life experience with customers, so they would be able to help you in assisting and understanding more about the course. This is designed in such a way that it is going to be intense. Sometimes some topics are intense, but we are having code labs and stuff to make sure it's from basic to advanced. And today's topic is day 4 for agent quality. The future of AI is agentic, and the success is determined by its quality. But Anand is here to walk us through the white paper overview. Anand.
Hi everyone. Thanks, Kanch. So hopefully you've read today's white paper. But over the last three days, as Kanch mentioned, we have built agent's brain, given it hands, given tools and the memory so it doesn't get amnesia, right? But before we deploy this complex machinery, how do we know it actually works reliably and can act autonomously or semi-autonomously in a production environment? And that's why today in day 4, we cover agent quality. And this is especially important for software that is inherently non-deterministic, like our agentic systems. So if you read today's white paper, you would have seen that we introduced a new framework built on 4 pillars of quality: effectiveness, which answers, did it achieve its goal? Efficiency, which measures the cost and speed of the agents. Robustness, which talks about handling errors gracefully. And safety, which talks about the agent adhered to ethical guidelines or not, or to what extent it did. The paper also proposed a strategic hierarchy, starting with the outside-in black box view to validate final outcomes, and then moving to the inside-out or glass box view to debug the actual reasoning trajectory, because an agent can get the right answer for the wrong reasons. So the journey matters as much as the outcome, especially for agents. To see that inside the glass box, we need deep observability built on the trinity of structured logs for raw facts, end-to-end traces. This will all allow us to follow the causal chain of thought and aggregated metrics for health trends. Thereafter, we then explored how to scale judgment of an LLM evaluation using LLM as a judge for rapid automated feedback based on reasoning, while keeping human in the loop essential for establishing the golden set of ground truth. All of these powers the agent quality flywheel, turning every production interaction into a data point for continuous improvement of the agentic systems going forward. But this differs significantly from the predictive AI quality measures, which we will hear about later in the Q&A session. That's it for the white paper. Off to you for the Q&A, Kanch.
There's a lot of content because it is a complex topic by itself. And here we have the judge, like the panelists here, who have experience in this from several different profiles which we have seen, and having the experience there, some of them, like we have authors as well, and we are super excited to have the panelists on stage. And these folks have been working with customers, and also two of them are white paper authors, one of them from the GDM research. Can I have them on stage, please? Oh, hi, everyone. Thanks for
Hello.
joining.
Thanks a lot for having us.
Thank you. Despite your busy schedules, thank you for being here and taking the time to answering the questions, because it is very relevant for the community to be able to hear from you. So we really appreciate your time and the engagement here today. Why don't you start, Dr. Vafa? Give a quick intro of yourself.
Yeah, sure. Thank you very much, Kanch and Anand, for having me. Hi, everyone. So I'm a generative AI specialist at Google. I'm based in Paris. I lead technical engagements focused on agents and multimodal AI. And I'm also co-author of the white paper that was released as part of this course on agent quality. And really excited to interact with our amazing community today.
Thank you. Thanks, Dr. Vafa. Thank you. Sean, why don't you go ahead next?
Hi, yes, so my name is Sean Gooding, and I'm a senior research scientist at Google DeepMind, working on autonomous agents. And yeah, really excited and happy to be here. So thanks for inviting me.
Thank you for, despite the schedule, thank you for being here. Appreciate it, Sean. Turan, why don't you go next?
Yes. Hi, everyone. I'm Turan Bulmuş, joining in from Amsterdam. I'm the head of Black Belts in the Applied AI Engineering org within Google. It is the same team as Vafa. I'm also one of the authors for this today's paper, so really happy to be here.
Thank you, Turan. Appreciate it. Doc Jive.
Hello, everyone. I'm Jiwei from NVIDIA. I'm a data scientist and a Kaggle Grandmaster. I'm working on data science and LLM-powered agents. I'm very happy to be here. Thanks.
Thank you, Jiwei. We are super excited to have you, particularly the Kaggle Grandmaster has been it's a real pleasure to have you here. So thank you. So we'll jump in quickly because this is what the community is waiting for.
Yes.
Anand, why don't you take it up?
Yes, thanks, Kanch. So first question, Sean, this is for you. Given your experience, what are the subtle failure modes or biases developers should watch out for when they start relying heavily on models to judge other models? What we discussed, the LLM as a judge in the white paper as well.
Sure. I think this is a really good question, because I think we like to maybe sometimes iterate quickly and assume that LLMs as a judge work well out of the box. But we know that these models do have biases, and that shows up in the way that they evaluate different types of generations. So I'm going to talk about four just at a very high level. So the first is preference bias. So one thing that we've seen in practice, and also there's many papers that discuss this, is that typically models will prefer generations that have been generated by themselves. So if you have a situation where there's multiple models that have made generations, and you're using one particular model to look at those generations and say whether they're good or not, it's no surprise actually if there is a preference there for the model to select the generation that was generated by itself, which is something to really look out for. And the second thing is verbosity. So interestingly, models quite often, if you have very confident long verbose generations, typically models will favor these, which is quite annoying, because I'm sure most of us are aware that these models do tend to act very confident and come out with very long verbose sort of answers. So that's something that you definitely see in these models as well. Another one too in multi-agent setups is sycophancy. So sometimes you might have two agents that are discussing or analyzing together whether an output is good. And same as how we have sycophantic behaviors when we talk to language models, if one model pushes back and says, no, actually, I think this is a really good generation, you do actually see that then the LLM as a judge might be like, oh, okay, sorry, maybe it is good. And so there are these dynamics that come about when these agents talk to one another. kind of about these generations. And then the final one is score bias. So typically, there's this phenomena where the models might try to hedge their bets, mainly because they kind of want to get the right answer. And so if you have maybe you have a prompt which is trying to score an agent trajectory on a scale of 1 to 10, don't be surprised if the model continually comes up with 5, because it's not, sometimes they're kind of primed to not make a strong decision either way. And this is interesting because you really do have to think about the way you operationalize or set up these prompts. Like, should it be like a number rating? Should it be side-by-side preferences? Because these things actually can make quite a difference for how well the model kind of is able to judge the output. And I think the final one too, which is probably more applicable to agents, is that one of the things we've seen is you might have a trajectory for an agent and an outcome, and you might kind of have an LLM as a judge to look holistically at this trajectory and outcome. And if the outcome was good, then irrespective of how good that trajectory was, some of the LLM as a judges tend to be kind of biased by what happened in the outcome and not really pay attention to kind of the intermediate steps, which can have quite perverse like long-term effects if you don't watch out for it. So yeah, I think it's a great question. And I think one of the ways we typically tend to adjust for this is it's really important to evaluate your evaluators and make sure that you have a test set so that you're not just sort of eyeballing it or feeling like your LLM as a judge is good. Like you really do that.
That's amazing, Sean. I think a few things to take out of this, which is really relevant for the community, is overtrained tokens, especially if you use a numerical output. Second thing is recency bias, the final outcome mattering more than the trajectory. And the third thing is evaluate your evaluator, especially with human correlation, right? Like matching to see if your evaluation correlates with how humans would do it. These are really great insights. Thanks a lot, Sean. Awesome. All right, shall we move on to the second question, Kanch? So this is for you, Jiwei. How do you say, in the spirit of evaluation, how do you see evaluation being different now for AI agents versus evaluation for predictive models in the pre-agentic, pre-Gen AI era?
Yeah, that's a great question. So evaluation for AI agents can be very challenging. So, on Kaggle, for every predictive model, usually we have a leaderboard. So you submit a prediction, there's a metric automatically scored. We want to adopt the same pipeline for evaluating the agent. So I think there can be 4 things that are useful for agent evaluation. First is a verifiable metric. So just like a Kaggle leaderboard, is it possible to set up a quantitative metric that we can just run and the agent cannot make shortcuts to get the correct answer? So sometimes that's very resource intensive and time consuming to set up such evaluation. So that's why we also need grounding. So LLM has profound knowledge in the pre-training stage. However, we really need to figure out, so how does the LLM-based agent reach to this conclusion? We want the agent to provide references and all the other evidences in the thinking process. Third, we need LLM as judge. So because agent can generate a large quantity of traces, so sometimes that's so overwhelming for manual review. So we really need automated, like LLM-based approach to go through those traces and look for red flags. Lastly, we do need some human review, especially for the code that generated by the LLM agent. LLM can be really creative when it is forced to come up with a really good answer. So sometimes it can make all these unexpected tricks, when writing the code. So we cannot fully cover all those corner cases in a predefined pipeline. So sometimes human has to jump in and look at the code and that's the last step for the evaluation.
Well, yes, that sounds definitely seems like, going from Sean and your answer, LLMs can do whatever it takes to convince you that they are correct and reach the outcome, but that doesn't necessarily align with our objectives. And especially quantifying this on a Kaggle Libra, really impressed with how you're managing it nowadays and in the non-deterministic era. Really great. Awesome. Let's move on to the next question, Kanch. So what are, this is for all three of you, Wafa, Dr. Wafa, Turan, and Sean. So what are the best practices or suggestions you would give for evaluating multi-agentic systems? And I would love it if you could draw from your applied experience from your customers as well to answer this one.
Yeah, sure. Thanks for the question. So first of all, the main challenge with evaluating multi-agent system is that even if you have the best model, and even if your individual agents are performing really well in isolation, the overall system might still fail. It's a bit like a soccer team. You can have the best players in the world, but if they are not working and coordinating together as a team, you might still lose the match, right? So my recommendation number one, in addition to the individual components, make sure to evaluate the interactions. The orchestration layer is really what makes or breaks a multi-agent system. And this is not something you should consider at the end. You should really think about this from the very beginning. You need to architect and design your multi-agent system to be easy to evaluate. Now, how can we concretely evaluate it? We just mentioned there are different approaches, and the smartest way is to combine several of them because we don't have one single approach that can captures everything yet. So we need to have a multi-layered evaluation with metrics that can, you can use them as a first filter to get the global picture of your system health. Then you can also use LLM as a judge. I want to add that it's very important in multi-agent scenarios to choose an LLM that has strong reasoning capabilities to handle these complexities of multi-agent system. And then, of course, for every safety critical areas or anything that involve irreversible decisions, you would need to invest in human in the loop, of course, to jump in and evaluate. The good news is that you don't need to implement everything by yourself. There are a lot of tools and frameworks, a lot of efforts in the industry to make this easy for you. At Google, for instance, we have Agent Development Kits, which is open source, the Vertex AI eval service as well. So they come with built-in features with LLM as a judge, even human in the loop patterns for production scenarios. So you can leverage those tools to speed up your evaluation process. And I just want to end here by saying that it's also very important to have the right mindset, because evaluation is not about achieving perfection. Evaluation is more about understanding deeply your system and find the best measurable ways to be able to improve it over time.
Amazing. Yes, I think a lot of great insights you shared in the white paper. Thanks for sharing with the wider community. For those of you who would like to dive deep into what she mentioned, please do give a read to the white paper and have a look at the summary podcast.
I love the tagline here, not about perfection.
Yes, but I mean, to some extent, I do believe that evaluating agents is so complex at the moment. You have a trajectory evaluation, trajectory interactions, multi-agent interaction evaluations. It's an open field, so there's a lot coming in this field. So, and thanks for everybody here who added their insights into the white paper and
maybe just a quick add-on here, because like if you were to go even one step higher, right? So from a system design and architectural point of view, it would be also interesting to highlight this deterministic software development practices as opposed to agentic development practices. I think that is something that is really, really important in this new agentic era. And then one thing that we see across the board with the customers is that evaluation should not be an afterthought. It should be a core component of your agentic design on day zero. Because otherwise, as you grow your sophistication in the agentic design, then it might be very much difficult to trace and look at where the failure modes are, and then you won't be able to trace them effectively. So that's why actually we would encourage the people who are just developing these agentic systems to have a different state of mind, especially as opposed to how you can develop a software in the past. Really take into account these agents are generating results non-deterministically. there is a probabilistic approach, like there is a probabilistic result out of it. You need to control for, let's say you need to safeguard it. You need to make sure that the agents are not producing false information. There is a lot more control that needs to be included. And that's not an immediate thought that when a software developer is building.
Yeah, definitely. This is using some of the best practices we already have. Thanks a lot, Turan. Perfect. Amazing conversation, guys.
Sean,
yeah, honestly, I thought those answers were really amazing, and I loved the football analogy as well. I mean, one thing that we've looked at in some of our agentic multi-agent systems is similar to the football team. If you take one player out or you make one player purposely bad, what's the impact overall, to try and get a sense of, for that node, how much does it impact like the overall kind of accuracy of the model? Because I think one thing to consider too is that with this, error compounds very quickly. So if you have like multiple interactions, even if they're kind of 10% off, each agent is 10% off, you really start to accumulate error very quickly. And so figuring out where the critical junctures are, or like the particular, so for instance, like we have an agent that does planning, and we found that if the plan to begin with is bad, then it will really massively impact and skew the rest of the results. So trying to figure out where those particular nodes are, similar to ablation testing actually in machine learning, where like you can, take one out or sub one in, or put in particular use cases which are designed to fail so that you can see whether it causes a catastrophic failure, is something that we've done. But yeah, I think both of those answers were really good.
Yeah, I think also another point here is that the more interactions that happen in an agent, multiple agents interacting with each other, the more the context explodes, because if all of the agents need the entire context, and as we know, LLMs are auto-regressive, so more tokens lead to a higher chance of error, the more interactions. So my personal insight here would be as well, try to keep the token count low, keep the interactions to a minimum what's required, and not load it unnecessarily. Yeah. All right. Thanks a lot. That was a very insightful conversation. Awesome. Let's shift gears and move on to the next question, Kanch. So, Juve, this is for you. What do you see as a core strength of the open source ecosystem over the next few years, especially in the area of agentic systems?
Yeah, so I really like this question. So I think open source large language model is going to play a critical role in the future world of agentic systems. Especially, let me take one specific example. We know, in the agentic system, many of the components, they are competing for compute resources. So you have this LLM, you have to run it on GPU or TPU. You have some code interpreter. You have all these kinds of tools. Some of them are also compute intensive. So eventually, when the LLM is open source, you have a great community support. So you will find all kinds of quantized versions of the LLM for all the hardware. So you can easily find like int8 quantized version for my 10 years old GPU. And by using that, you can save some compute space. You can save some compute resources and memory space for other components in your pipeline. You can make it really flexible and working just as good as a cutting edge new hardware. So I think this customizability and flexibility is a key advantage of the open source models.
Well, yes, especially if I must say, the quantized models, quantized and distilled models in the open source community have reached such a threshold wouldn't have been imaginable 2 years back. If you see the quality versus non-open source models, they've been increasing steadily. So I'm really excited to see more of what's coming. And for those of you who would like to know about quantization and distillation and all of these techniques a bit more, please refer to the Foundational Models white paper, which I had the pleasure of authoring in our previous courses, which we go into more details of how all of this works. All right. Awesome. So Kanch, would you like to take some questions from the community next?
Oh, thank you. So this part comes from the community based on the Discord questions you have posted in the expert group which Brenda had created. So please post your questions continuously. And this was for Sean from Akil026720. How do we build a robust, scalable golden set for non-deterministic AI agent regression testing, specifically using an LLM as a judge to validate novel, correct trajectories?
Yeah, quite a mouthful. Yeah, so I think it's an interesting question, and I think we said earlier, evaluation's not exactly an exact science, and typically what we're trying to do is build up a framework of many different types of evaluation folded in throughout the entire process, right, to be able to identify where we're going right or wrong. And it can be complex then when you make changes to your system to know exactly how that has impacted at different points. So typically what we do, so there's at a high level, two different areas of evaluation. One is task completion for our particular agents, and the other is looking at trace quality. And that can vary, but there's many different intermediate steps that you might want to evaluate. And for our golden test set, what we found was most useful was really designing one that had that gave us really good insight into the different capabilities of the agent. And instead of looking at aggregate accuracy or aggregate sort of task completion metrics, looking at the error distribution and how that error distribution might change when you introduce different components. And, I think it's interesting, this idea about novel traces as well, because this is something that can be quite hard. It's always an evolving system. Even when you start looking at LLMs as a judge, the way you calibrate those at the beginning might actually change. It's a process that you're continually updating in tandem with building the system itself. And so when it comes to novel trajectories, one of the things that we've looked at for we haven't seen these types of trajectories before, how do we evaluate them? Or how do we know whether our LLMs as a judge are actually working well for these? So there's different tips and tricks that you can use for that. One, looking at self-consistency. So, if you have an LLM as a judge and you run it multiple times on novel trajectories, is there much variance there, or is it giving the same answer? Because that can give some indication as to the certainty of your autorater. We call it autorater, but LLM as a judge there. And also, typically people tend to use ensembles of different models when you're looking at LLM as a judge for different novel traces. If you have a bunch of different models, how likely is it that they agree that that particular novel trace is good or not? And that can give some type of insight into, again, the certainty as to whether that's a good trace. I think one thing that we've used, which is probably something that is not very well utilized at the moment, but we found very useful, is you can actually look at novelty of traces or novelty of trajectories using clustering. And we use a lot of unsupervised clustering to kind of visualize the space of trajectories so that you can actually see, if they start being different or there's particular novelty because you've introduced a new tool or something like this, you can start to see how a new cluster of trajectories might appear. So typically this is visualization strategies, which also can help you inform building this sort of golden robust test set as well. But I am actually very curious what other people think about that too, because I mean, it's a really great question.
We have one thing we have observed over the last 3 days is every question becomes a capstone project by itself.
Yeah, I was just gonna say, we love to see this in the capstone project.
Yeah, so that happened over the last couple of days, and I almost feel like this is a capstone project by itself for the person who asked the question. And when you mentioned about how it is the question is about novelty, and we talk about consistency, and novelty and consistency kind of are not in the same league, but your clustering mechanisms are some of the ways which we can try to see where we would be able to, understand deviation from the results. So thank you, Sean. Appreciate it. The next question is from Yassine for Dr. Vafa. When using LLM as a judge for agent evaluation, how can we ensure the judge model itself is reliable and does not introduce new bias into the quality scoring?
Yeah, thanks for the question, and really good points. Indeed, we can introduce an agent, an LLM as a judge, and it comes with its own problems, especially if we don't know how to use it properly, right? So one of the most common mistakes I see across teams building agents is that they just plug in the LLM as a judge, and they just let it give its opinions in a kind of a freestyle manner, without any guidance. And that's actually where it becomes prone to bias and random errors. So the best way to improve that or to avoid this is by using what we call rubrics. A rubric is basically like a structured scoring guide. It's like a checklist of all the specific dimensions that you care about. It can be, safety, performance, whatever matters for your domain or industry or area of expertise. And instead of asking the model a very vague questions like, hey, is this good or bad? You're asking it to reason step by step against some clear and predefined criteria. So these structures keeps the evaluation more consistent and more aligned with your quality goals. Now, there are also another path that you can take if you want to build more trust in your LLM as a judge, which is fine-tuning. You can always fine-tune the model on human preferences or ground truth examples. Of course, this is more costly. It's also slow, but it's always about trade-offs whenever we talk about evaluation. And as I mentioned earlier, we all agree today that we need to rely on multiple approaches. We need to have multiple evaluation angles all working together. And I like what you mentioned, Anand. This is also a space that is evolving. Agent evaluation is really an active research area. And a lot of open questions. We don't have all the answers yet, but it's also a very exciting field to explore because agent quality is directly correlated to user trust. And the better we get at judging the quality of agents, the more trustworthy and reliable they will become.
Awesome.
Awesome. Thank you, Wafa. This question, that LLM as a judge, that concept itself, I feel like there is more to it than the 70-page white paper which was published with other components. So thank you for adding more color to it. The next question is from Sharon Ginsberg for Turan. Are there any established quality protocols or key products that we can use to improve agent quality for specific use cases instead of building our own process?
Yeah, very good question, right? Especially in the context of building and deploying agentic workloads to an enterprise setting. This becomes a very critical question to handle. And then the way that I would like to just approach this question is to take, let's say, a different approach on what we mean, what we do when we are experimenting and when we just deploy agents to production, right? So the protocols wise, let me just immediately address that one as well. Luckily, the whole, let's say, software development community take this agentic workloads very seriously, and then immediately they just come up with standardized protocols on multiple interactions between within the agentic system. The first one is that we had the MCP for tool utilization. We also released A2A for agent-to-agent communication. We have also the A2P, for example, for payments. And these protocols are just going to be coming up quite a lot. And then from an observability and tracing perspective, we first need to first divide it into the deterministic part of an agentic workload versus a non-deterministic part of an agentic workload. And then for the deterministic part, we don't need to reinvent the wheel, right? So people have been building systems and putting them to production. We have a very established DevOps practices, and there's a lot of, let's say, standards on building, let's say, observability around how the system logs should work. And then, I'm not going to go into that, right? So having said that, the non-deterministic part is basically where it becomes quite interesting. And that's when the whole tracing of the agentic work is taking place, and how we control for that is really important. The way that we as, let's say, Google is approaching through this within the context of, for example, agent development kit is to utilize open telemetry to be able to start building logs of also traces, but also system metrics about how an agent is interacting. So there is an opinionated way of just doing this, but then more importantly, there are different frameworks just doing the same thing as well. So this goes back into how you're going to integrate this non-deterministic part into your deterministic already existing observation logs to your system. And that is, let's say, a decision, an architectural decision that needs to be made. But then one thing, as a best practices perspective, what I would like to just highlight is that first, make sure that you're tracing everything that is needed, what the agent does, what the LLM calls are done. You even, for example, think about just logging your thinking budgets, like what the thinking tokens are doing. And then you need to just make sure that your outputs are also, let's say, taken care of, and the system metrics around it, right? One thing that is really, really important is for security purposes, for example, the authentication. What the tool is using for if an agent says that I am going to use this tool and I'm going to do that via this authentication, you really need to make sure that all these metrics are accounted for. So going back to the first part, let's say very clearly, very shortly, is that yes, we have the development cycle and we have the deployment cycle. The development cycle, we have this, let's say, ADK web, where you can just really experiment it quite quickly, and it just creates all those logs directly. You can just monitor them. But then basically you need to have a path to be able to, an integrated, let's say, infrastructure that is able to take your workload from experimentation to production very seamlessly, and have the same compatibility of each logs on both experimentation and productionization.
One of the things about building agents, right? Like, I feel like the first 3 days, which we did, is all exciting because you're seeing it live. And this is, I would say, kind of boring in the back end for a developer, because for them, like, should I do it? Because it's not showing results. But this is the most important part, to make sure your agent is performing well. And the scaffolding you mentioned, right? Like putting together so that the process is there as you build, helps your development quicker. So a developer should care about it, and make sure that you are aware of the techniques and process this needs to be established. And one of the reason behind the question is probably also that making sure, hey, how do I make sure there's one process to establish? But it's not necessarily one process. It's making sure you're aware of all the processes and create an approach for your organization of what best fits. This has been amazing. Really grateful to have all of you here during this time, and making sure you're able to answer questions for the whole audience. Like, we have 3 more segments to go, but I really do appreciate you taking the time, coming, answering the questions. The community loves it. And as you could see in the live chat, as it keeps coming up, like, folks enjoy hearing from the experts, and we are looking forward to seeing all the momentum in the Discord and other channels. And please keep us engaged with it. Thank you so much for all of your time. And now on to the next exciting thing. We talked with Jive just now, and he has a demo which he would like to share from his how he works through the data science agents. Jive.
Hi, thank you so much. Yeah, today I'd like to share how I build GPU-accelerated data science agents. The traditional data analytics workflow, or the ETL, is an iterative and interactive process. It takes time to write correct code, and we need to wait for the program execution, examine the results, and then we can move on to write codes for the next iteration. So this process takes time, and how fast we can iterate decides the quality of the analysis. That's why I believe LLM-powered data science agents can help us automate and accelerate this process. It can do tasks from creating a single plot to writing a full data research report, just based on simple prompts. So to achieve this, we need a multi-agent system. For example, if we want the agent to create research report based on a data set, we could have these 4 agents. So the planner can make plans and break down tasks. And the coder is to write the code and execute the code to generate all the artifacts, include visualizations. So the vision agent can interpret the vision, all the visualizations, and convert them to natural languages. So the writer agent will combine all the insights and write a report. If we look at each agent, it can be as simple as LLM with some tool calling. So in the demo I'm going to show shortly, we create this simple agent architecture from scratch. We are using the NVIDIA Nemotron LLM. And one thing I want to highlight is the NVIDIA codelabs library. So we're going to use it as a tool to accelerate the data processing. For example, here is a standard LLM tool, a Python interpreter. So we can simply add like one argument, use GPU, to let the LLM to turn on GPU acceleration. So the cool thing is LLM doesn't need to know how to run codelabs. If the LLM already knows pandas, which is most LLM knows how to write great pandas code. So pandas is a very popular package in data science. So it does tabular data processing. However, it can be slow because it's on CPU and once dealing with a large data size. codelabs has this cool feature called zero code change pandas accelerator mode. So basically, you only need to add 2 lines of code, import codelabs.pandas and codelabs.pandas.install, and all the pandas code below it will just work, but they will be accelerated on the GPU. So in our experiment, the data science agent, you can see that the data processing time is actually longer than the LLM inference time. So you can take 10 seconds for some query on a 2 gigabytes or 5 gigabytes data set. So the codelabs can shorten the time to just 1 second. So our agent has many advanced features like dynamic context management, efficient tool calling, customized chat template for quantized model. However, unfortunately, I don't have time to explain all of them. So please find the details in our write-up. Once we are familiar with how agent works, we can, when we want to deploy it to the production, I recommend to use a more powerful agentic framework. For example, the Nemo Agent Toolkit from NVIDIA. So it is an open source AI framework. It is enterprise ready, composable, and reusable. And it works with most of the popular frameworks you're already familiar with, like the Google ADK, Longchain, etc. Okay, yeah, so let's take a look at the 2 examples, 2 demos. Let me switch tab and share the new tab. Awesome. So this is an interactive demo. So I'm running it lively. It is running on Kaggle kernel. So you can see that we have already launched the LLMs. So they are running on the GPUs on Kaggle kernel. So here we want to explore a data set interactively, but just as asking questions. So for example, we can ask the LLM to read this data set and tell us the column names. So if you look at the output of the LLM, it will first generate write a code and call the tools to execute the Python code. So the execution is failed because this data frame variable df, it doesn't exist yet. So the LLM can reflect on this failure and generate a new code. So you realize we have to read the CSV file first, and then we can print the column name. So yeah, and so here the agent can tell us the correct column names. So for example, we can ask other questions like how many rows and columns. So this data set is an e-commerce data set. So it has 9 columns and 42 million rows. So it's about 5 gigabytes on disk, but when loaded, it takes like 10 gigabytes on the GPU. So the LLM, so this tool calling is super fast. So when we look at the trace, you can see, yeah, let's look at another example. So if we just want the first 5 rows from the data frame, so the code takes like 1.5 seconds. So it's considering the data size and and the GPU we have. So I think it's pretty fast. Okay, let's run this query lively. So how many unique brands are there? So the agent is going to reason about this request. So because it has all these history, so of these data frames, this data frame already exists, and the agent knows its column names. So the agent can write this code and execute it and tell us like there are 3,445 unique brands, and we can ask like what's the most popular brand. And yeah, so again, so the agent maintains this history, but it also tries to manage the context in the optimal way. So it actually removes, all the to-callee traces after each conversation. So it tells us like the most popular brand is Samsung, and we can ask like, so what's the mean price of all the Samsung products? We can even ask the agent to create a visualization. So here it tells us that this is the mean price of Samsung product. And here it writes the code and generates this plot and show us like the top 10 brand by count. So we can also ask, the mean price of the top 10 brand. So yeah, you can see here, so it maintains this history. So it's like chatbot, but now it can execute code. So and everything runs on the GPU on the Kaggle. So you can see all these metrics, like how much GPU and CPU is utilized. And yeah, so eventually we have this plot. Okay, so this is the first demo. And in the second demo, yeah, let me share a new tab. In the second demo, I want to show how we can create a full report from a data set. So this is a much more complicated task, and it requires a more capable LLM. We're going to use the NVIDIA Nemotron Super 49 billion parameter LLM. So due to the model size, we can no longer run it on Kaggle. So we're going to use the cloud, the NVIDIA NIM LLM inference on the cloud, and use API key and use this LLM to do it. So I'm not going to run it. As you can see here, it takes about 5 minutes to generate this report. I'm just going to go through like the process. So we want to start with the configuration. You can get a free API key from this website, and you can save it as a Kaggle secrets, like this is the NVIDIA API key. And then we just install some helper utility libraries and functions. And so basically you specify a data set. So Kaggle has a rich data set ecosystem. You can find a lot of different tabular data set. We're going to use this earthquake data tsunami data set. So you specify this data set and you can provide a simple prompt. So I'm just going to say, explore this data set. And we can call this library, run data explorer. So it's going to generate a lot of traces. So it's going to write code, create visualization, verify if the plot is successful or not, interpret the plot, write the insight as a report. So eventually, you're going to get this PDI file, and so it has. Yeah, let me try to make it bigger. Yeah, so it has everything. Yeah, let me actually make my screen. Okay, yeah, maybe this is better. So it's going to generate this report. So it has all the insights organized logically, and it has all the plots generated by the agent. So for each visualization, so you can see that, so it tries to analyze this figure and collect the insights from each visualization and draw a conclusion in the end. So if you check the output of this demo, so you can also find, in addition to the report, you can also find all the intermediate outputs, like all the Jupyter notebooks it generates and all the figures it generates. Okay, let me get back to my presentation. Yeah, so hopefully you can enjoy these two demos and try it. You can reproduce every one of them by just running them on Kaggle kernels. And if you have any questions, please reach out to me. Thank you. That's all.
Thank you so much, Jive. This demo is amazing, particularly the data science piece of it. I have seen with my experience with data, it is hard to get things correctly. I can't wait to try it. So thank you for sharing and for the write-up as well, because that was very self-explanatory as you were walking through. So thank you.
Thank you.
Thank you so much, Jive. Now on to our next segment, which is the code labs that folks have experimented already. Can we have Sita on stage, please? Sita has been actively engaged in the Discord community, so folks know her already by this time.
Thanks for the intro, Kanch. Really happy to be here. Thanks, Kanchan. And so, hi everyone. My name is Sita, and I'm a developer relations engineer. And I've been working very closely with ADK team since the beginning of this year. And AI and security are my two biggest passionate areas. And I'm really happy to be here on the live stream today to talk to you about the day for code labs and walk you through the important concepts that we have. So let me go ahead and share my screen here. And for the first notebook, we have the agent observability, and the second notebook will be about agent evaluation. But before we dive into the notebooks, I want to take a quick pause, a step out, and then do a quick refresher of what you've seen since the beginning of day one, right? So you learned how to build agents, how to add tools, and then you also learned how to add sessions and memory to your agent, right? And at this point, you could say your agent is a complete unit by itself, right? And you can deploy it to production. But hold on, no, not yet. We need to do eval and observability first. And today's code labs are all about why do you need to do that and why is it so important? With that, let me jump into the first code lab, which is agent observability. So what exactly is observability? And I like to tie things in agentic land back into software engineering practices that we've been following for so long. And on that note, agent observability is basically three things. It's logs, traces, and metrics. So logs are print statements or log statements that we put in our application code, which tells you what happened at a specific point of time, right? And traces, the second pillar, are essential because they connect all the logs to form a single cohesive story, which tell you what happened when you go debug your agent. And then the third is super important, which are metrics or numbers, which tell you important numbers like what is your agent's average latency over the past month, or what has been the failure rate, which are super important to have. And with that, let me actually go into the crux of this notebook itself. We're going to skip a little bit of setup steps because these are all the same that you've been doing since day one. So I'm going to go skip into the hands-on demo we have for you today. And let's start with the agent's code itself, and I'll jump to the UI screen in a moment. So the agent that we have today here is a research paper finder agent, and it has one simple goal. When you give it a prompt asking for get me the research papers for quantum computing, it's going to use the Google search agent, find the list of papers, and then it is going to use a simple Python function that you see here to count how many papers the Google search agent returned, right? So seems pretty simple, right? But hold on, we have a deliberate flaw in the agent, which we'll debug. I'm going to go ahead, switch to this other tab for the ADK UI. And yes, now you see it. So I've already fed in the prompt, and then you see that the agent returned all the papers that it found for all the quantum computing latest papers. And we also see at the end of the response, if you look, there's a line saying it's a total of 1,367 papers, but we barely see like 15, 20 papers listed here, right? So let's see what happens. I'm going to go click to the trace, look at the specific span that says what happened. So this is the span that returned this absurd number, 1,367. Okay, let's see what is being even fed to this specific function. I'm going to click on the span right above it. And this is the event that for the agent when it called the function. So you see that the agent called the count papers function, and then it passed an argument saying papers. But hold on, we might have found our error. So the papers is a single string instead of a list of string of papers that we were expecting. Let me go back to our notebook and we'll verify this. Yeah, we're right. So we're counting the length of papers, but we are passing it as a single string. And there you go. We've just debugged our very first agent with ADK Web UI. But I want to take a moment, pause here, and see what would have happened if we didn't have the observability here, right? We would have had to manually debug our code looking for errors. But it is also complex because agents are non-deterministic. So it might have worked for one prompt, but it wouldn't have worked for another prompt, which makes it even more crucial to have observability implemented for agents. Cool. We're done with the first part of this notebook. So for the second part, we're going to see how do you implement this observability in production. And for that, ADK actually provides us a little nice convenient components called plugins and callbacks. Because if you've seen the agent code that we just saw, there was no way for us to add logs or print statements, right? The only place where we could have added it was a Python function that we had. So now we need a way to hook into an agent and to add these log statements. So if you've seen the live stream for yesterday, you would have learned about callbacks, or if you've done the notebooks as well. So callbacks are nothing but Python functions which can plug into your agent's lifecycle at specific points. Like for example, this callback here can plug into before an agent runs and run this piece of Python code. And this can plug into after an agent runs, and this before tool, after tool, and similarly. And plugin is what combines all of these and then makes them applicable to a wider set of sub-agents, tools, and everything. There's a bunch of theory for you to read here to understand this more in depth. But I'm going to go to the next important concept here, which is why do we need this? Plugins and callbacks, right? So basically callbacks, like we've seen, is a Python function where you can add log statements. And this makes your life even simpler by adding observability wherever you want to in your agent. So ADK also makes this even simpler for you if you just want standard observability in your agents by giving you an option for a built-in logging plugin. So this plugin, like built-in tools, comes built-in with ADK. And all you need to do is basically these two lines. Import the plugin and then add it to your runner. And then when you run the agent the next time, you would see built-in observability like this. Like when the user received the message, when the invocation is starting, LLM request, response, all standard observability built in. So let's quickly recap what we've seen in this notebook before we move to the next. We saw three important things, which is use ADK Web UI when you're in development, when you're debugging your agent. In production, you have an option to use plugin and callbacks. If you want standard observability right out of the box, use the built-in logging plugin. But if you have custom requirements, then you can build your own custom callbacks and plugins. Cool. With that, let me switch into the next notebook that we have for the day, which is the agent evaluation. Yes, I'm sharing the right one. Cool. I'm going to start with a couple little tidbits about agent eval. So right now, in the previous notebook, what we saw was a more reactive approach to problem solving, right? You know something is wrong with your agent and we want to debug, and we looked at the logs on how to debug. But evaluation is more of a proactive approach where you catch quality degradations in your agent much before it happens. And that's why both of these are very complementary to each other. And the second thing I want to share is evaluation is not standard testing. And this is actually a misconception that I had when I started learning agents. I thought testing was eval, but I couldn't have been more wrong. So in standard applications that we write with deterministic code, when we test them, we basically create unit and integration tests, right? And as long as our code doesn't change, no matter how many times we run the code, we expect it to pass the test. But that's not the case with agents because they're more non-deterministic, which means it is not only essential we test the final response from the agent, but it becomes even more important that we test the trajectory, meaning all the steps that the agent took or all the tools that it used to get to that response. And you've seen experts today talk about different evaluation measures, what you should be considering, and those were pretty amazing. So we also have a bunch of links in the resources section for you to read more on different kinds of metrics that you could use. But for this notebook, we'll be focusing on two parts, which is how do you do evaluation with ADK Web UI, and the second part, how do you do it in production? With that, I'm again going to skip a bunch of these setup steps and go into straight to our agent, which is the interesting part. right? Cool. So now we have our agent, which is a very simple agent here, which mocks and home automation. So it says you're a home automation assistant. You control all the smart devices in the house, and it has access to one tool, which is set device status. So whenever we specify saying, can you turn on the lights in the hallway? It's just going to return, okay, I've successfully turned it on. If you say turn it off, it's going to say, okay, I've turned it off. Pretty simple, right? But this would show us the power of evaluation when we do it in ADK Web UI. So I'm going to briefly stop here and bring up the ADK Web UI for us so you can see how this works in practice. Cool. So now you see I'm sending a prompt saying, turn on the desk lamp in the office, and we get a response saying, okay, it is now turned on. But let's go ahead, click the eval, create a new evaluation set in the UI, give it a name, and I'm also going to go add in the current session to the eval set, meaning the conversation that we have in the right side will now be persisted in the evaluation set. I'm going to go ahead, run the eval, and you see two metrics which we've seen, response score and the true trajectory, right? So let's go ahead, run the eval, and let's see if it passes. Yeah, it does. Yeah, good for us. It passes, but now I want to do something different. Let's go edit our ground truth that we're seeing here to see if our evaluation fails. Okay, I'm going to click on the case ID again, and then go edit this case that you're seeing here to say, okay, the desk lamp is off now, it's not on. And this is basically a ground truth. So basically when this prompt runs again, the agent will be comparing the ground truth against what result it got. And that's how we know if an evaluation passed or failed. So let's click on the start eval again. And we see, yeah, perfect, it failed. And you also get the math score, the threshold, why it failed, what's the response, and so on. So I'm going to go back, share the notebook again. And that brings us to the end of the first section for this notebook. And the second section, let me scroll to the relevant section here. And yes, the one final section here is how do you do this in production, right? So what we've seen now is how to evaluate with the ADK Web UI. But in production, you would need to do 3 simple steps, which is replicate all the things that we've seen locally. So we create an eval config and we give the criteria tool trajectory score and response match score. You can also give several other criteria like safety to evaluate if an agent returns safe responses, or hallucination to catch if an agent actually hallucinated a response. So step 1, define your criteria. Step 2, we'll be creating test cases that we just saw in the ADK Web UI, right? So we'll be feeding this ground truth, and there are several ways to create this, which we've listed here on how you can do that. And step 3 basically is for us to run the ADK eval command itself. So if you are running this from a CI/CD pipeline perspective, there are 2 different options. You can use ADK eval CLI command, or if you're already using PyTest to write your unit and integration tests, you can also use PyTest with to run your evaluation. And I would love for every one of you to take that as an exercise to replace ADK eval with PyTest and see how that's working. So let's go ahead and see what this ADK eval returned to us. We see detailed responses for each of our test case, and it says both test cases failed. And you can see why it failed or why it passed and what was the threshold score for results. And here you also have a sample. How do you analyze this results section? With that brings us to the end of the code lab with one small section here, which is also a very interesting exercise that I want to leave you with, which is user simulation. So you see the test cases that we created were all fixed in JSON, right? But using user simulation, which is a feature that was recently released in ADK, you can just pass a conversation to an agent, and then the agent takes a conversation, creates its own evaluation plan, and then does it, so that you won't need fixed test cases anymore. The links to the documentation are down below. So go ahead, try to see how you can use user simulation to replace the fixed test cases. With that, we've now successfully completed both the code labs. A quick refresher for this: we've seen how to evaluate agents with ADK Web UI. We also saw what different metrics are, and then how do you evaluate in production using both PyTest and ADK CLI command. with that, thank you so much for sticking with us on the live stream, and really appreciate all the great conversations that's coming in Discord. So happy to be here, and keep the questions coming. We're more than happy to have a conversation. And back to you, Kanchan and Anant.
Thank you, Sita. I love how you broke the agent first and then able to demonstrate, because if I recall in the day one, that was what happened. Folks were like, why is my Google search not working with ADK web? Like, this is how you fix it. You need to first be able to debug and look at it in the debug option with ADK web. So thank you so much, Sita. We really appreciated it. And the folks have already started testing it, right? I keep seeing feedback in the Discord. So please continue to engage there. Sita is active participant in the Discord, and she is there to answer as well. So thank you so much.
Absolutely. Really happy about that. And I see so many debug questions for yesterday's codelabs as well. So use all these tools that you learned today to debug away. Thanks, Kanch.
Thank you. Thank you so much, Sita. Bye.
Thank you.
Now, on to our most exciting session, Anand, which is the pop quiz, where we see all our folks jumping in with answers. And let's just jump in. Anand.
Yes. So let's see how closely you've been reading and listening to us. Your first question: why do traditional QA practices often fail for AI agents? Your options are: A, agents are just too slow to be tested by traditional methods. B, agents are non-deterministic, meaning their failures are often subtle degradations of quality rather than explicit crashes. C, agents do not use code that can be unit tested. Or D, traditional QA tools cannot connect to LLM APIs. So your answer will be shown in 3, 2, 1, and the answer is B. I think we talked a lot about this QA, so this should be a no-brainer. The whole challenge with LLMs and agents comes with the non-determinism and the way they try to convince you that they're right without being right sometimes.
Yes, and I see a lot of correct answers popped up, so we are good.
Yeah, exactly. All right, next question. What are the 4 pillars of agent quality introduced in the framework you read in the white paper? Your options are: A, accuracy, precision, recall, and F1 score. B, speed, cost, latency, and throughput. C, effectiveness, efficiency, robustness, and safety. Or D, planning, tooling, memory, and orchestration. So think about it. I see a lot of you answering this already. Great. Your answer will be shown in...
You shared that in the highlights too.
Yeah, definitely. 3, 2, 1. Your answer is C. So yes, this is the 4 pillars of the agent quality, and I shared this in the very beginning of the live stream as well. Moving on. So question number 3. In the context of observability, what is the difference between logs and traces? There's a subtle difference here. Your options are: A, logs are aggregated health scores, traces are raw text output. B, logs are for developers, while traces are for product managers. C, logs are discrete timestamp events, while traces connect these events into a full narrative. D, logs measure performance, while traces measure cost.
Where do you get these answers from?
Yes, so think about that. The difference is subtle, but especially crucial for agents. Your answer will be shown in 3, 2, 1. C. So remember, traces are for the trajectory evaluations end to end, while logs are the individual parts which help individual events which are logged, not the end-to-end story for the agents.
And the white paper in detail covers this, so it's good to have.
All right. Question number 4. What is the outside-in evaluation hierarchy? Your options are:
One second. Yeah.
A, evaluating the agent's internal reasoning before looking at the final output. Or B, validating end-to-end task success before analyzing their internal trajectory? Or C, relying solely on external user feedback to judge agent quality? Or D, testing the agent only in production environments? So hopefully you have had some time to think. Your answer will be shown in 3,
I see a lot of wrong answers here.
1, and B. Yes, so outside in is look at the end result and then look at the journey which led you to the destination. All right, last but not least, question number 5. What is the primary purpose of the LLM as a judge paradigm? So we discussed a lot about this. This should be very straightforward. Your options are A, to use a powerful LLM to scalably score qualitative outputs based on a defined rubric. B, to replace human evaluators entirely to save money. Or C, to generate synthetic training data for the agent. Or D, to act as a router between different agent models. So think back to the discussion today and the white paper and all the previous white papers. We referred to this a lot. Your options, your answer will be shown in 3, 2, 1. A. I think that should be. All right. Hopefully you reinforce some of your concepts, and that brings us to the end of today. See you tomorrow. Tune in.
Yes, and see, this tomorrow is the most important part, in my opinion, because it's not just building an agent. Productionizing is the super hard piece of it, and we have excellent Q&A experts who are coming up. So please do come, join, and the capstone course will be announced as well. So please do join in tomorrow, same time, for day 5. Prototype to production, our last day with us. Thank you for staying with us in the journey. See you same time.
See you tomorrow. Bye-bye.
Bye.